Welcome back, everyone, to another deep dive. This time we're diving into the world of AI and big data. It's incredible how much data we're generating and analyzing these days. Imagine trying to do it all by hand. Back in the 1880s, the US Census took almost a decade to process data for 50 million people. That puts things in perspective. What's amazing is that just a decade later, the 1890 census was completed in 18 months, all thanks to Herman Holleritz's invention, the tabulating machine. Using punch cards, this early machine really paved the way for how we use machines to analyze data today. It's mind-blowing how such a simple innovation revolutionized data analysis. Today, we're talking about ChatGPT's Data Analysis Extension, or DA for short. Think of it as your personal AI data analyst. You can upload your data and just ask questions in plain English. DA translates your questions into Python code, does all the analysis, and gives you the results. DA can load data, clean it, analyze it, and present it in a way that's easy to understand, making data analysis more accessible. For example, remember the laptop price data set from Kaggle? DA can load that massive data set, clean it, and get it ready for analysis in seconds. You could compare different brands, see how prices vary based on different features, and even find the best deals, all without writing a single line of code. But before we get too carried away, what about the limitations of AI? We've all heard about AI making mistakes or hallucinating information. It's important to remember that human oversight is crucial. We can't just blindly trust any AI output. We must use our judgment to make sure the results make sense. So, it's like a partnership. DA can create insightful visualizations. With the same laptop dataset, you could ask DA to show you the frequency of laptops by company, and it will instantly generate a bar chart. You can even ask it to create charts showing the distribution by CPU type, brand, or GPU. Basically, you can uncover trends and patterns in your data with just a few clicks. It's a huge time saver compared to traditional data analysis software. But remember, DA isn't perfect. It's still under development, and it can make mistakes. For example, when we asked it to create a histogram showing laptop prices, it assumed we wanted it on a log scale, which wasn't what we needed. So it's important to double-check and not take everything for granted. DA is really good at correlation analysis. Using the Duke Forest dataset, DA performs a correlation analysis to see how different variables relate to each other. For instance, a strong positive correlation between price and area would mean that as the area of a property increases, its price tends to increase as well. DA uses Pearson's correlation coefficient, a common method, but while DA presents results in a user-friendly way, there's a lot happening behind the scenes that we might need to understand fully. Even though DA gave good insights for price analysis, it didn't immediately try to build a model to predict prices. So, even though it's smart, it still needs some direction from us. It's not going to take over the whole analysis process just yet. When we asked DA to do a linear regression model, it outlined a very thorough process, pre-processing the data, splitting it into training and testing sets, building the model, and evaluating its performance. But there were potential issues. For instance, DA didn't initially address things like residual plots, which are important for checking the validity of the model, and it didn't consider that the model might predict negative prices for houses, which wouldn't make sense in the real world. We also explored decision trees, random forests, and support vector regression, SVR. DA even recognized a potential problem with SVR, which could give a negative R-squared value. But it still used R-squared to evaluate these models, which isn't ideal for nonlinear models. So again, take the evaluations with a grain of salt. While we were exploring different feature selection methods, the calculations were interrupted by a technical glitch, but we just started again. This time, we asked DA to fit a simple linear regression model with just one predictor. It showed that area is a key indicator of property price, which makes sense intuitively. However, DA didn't provide the coefficient, values, or significance testing unless we specifically asked for them. When prompted, DA generated helpful diagnostic plots and identified violations of key assumptions for linear regression. But it didn't provide confidence bands or statistical tests for normality, which are standard things that should be included. So DA is great for an overview and guidance, but it's not quite a seasoned statistician. DA acknowledged that neural networks can capture nonlinear relationships and suggested scaling the features and building a simple architecture. However, it left a lot of the details up in the air, such as the specific architecture, activation functions, and optimizer choices. It's like DA gave us the ingredients for a meal, but didn't give us the recipe. We also hit another roadblock. DA needs TensorFlow for neural networks, but it wasn't available in its environment. However, it provided draft code for us to run in a separate environment with TensorFlow. The code was well documented, making it easy to understand and use. DA automatically analyzed the Duke Forest dataset for clustering, and suggested potential applications like dimensionality reduction and anomaly detection. It even implemented k-means clustering and used the elbow method to suggest the best number of clusters. The elbow method helps figure out the best number of clusters by plotting the sum of squared distances within clusters against the number of clusters. The point where the plot bends like an elbow suggests the optimal number, but DA mentioned that it doesn't always find a clear elbow, so we still need to use our judgment. This has been an amazing journey, exploring data visually and diving into supervised and unsupervised learning. It really shows how powerful DA can be. But as we've seen, it's crucial to understand statistical concepts to use it effectively. DA is a fantastic starting point, but not a replacement for human expertise. It's like a powerful telescope that lets us see far into the universe of data. But we still need astronomers to interpret what we're seeing. Before we move on, I have a question for you and our listeners. Do you think ChatGPT's DA will become the new Excel for statistics? Could it revolutionize how people approach data analysis? It certainly has the potential to make data analysis more accessible, but whether it'll completely reshape the field will only time tell. We'll have to see how DA evolves and how users adapt to its capabilities and limitations. For now, let's zoom out a bit and talk about the bigger picture of data analysis. DA is a powerful tool, but it's just one tool in a whole toolbox. We've come a long way from early punch card systems to sophisticated programming languages like R and Python. But the fundamental principles of data analysis are still the same. We still need to define our research questions, choose the methods, clean, and prepare our data, and interpret the results critically. And that's where human expertise comes in. It's not just about crunching numbers, it's about thinking critically and using data to answer meaningful questions. Different types of data require different approaches, and understanding the data itself is crucial. Even though DA can handle a lot of data formats, it's still our job to figure out the best way to analyze it. Human oversight is crucial, even with the most advanced tools.